We will now get into the third lecture of the series. We have with us Professor Ashutosh Sharma, who is the former Secretary of the Department of Science Technology, Government of India. He is an Institute Chair, Professor, and CV Sheshadri Chair, Professor at the Department of Chemical Engineering of Indian Institute of Technology, Kanpur. He is the founding coordinator of the DST Thematic Unit of Excellence of Soft Nanofabrications and chairman of Center for Environmental Science and Engineering at IIT Kanpur. He is best known for his pioneering research work in the areas of colloids, thin films, interfaces, adhesives, patterning, and in the fabrication and application of self-assembled nanostructures. We are fortunate to have Professor Sharma physically here addressing all of us, and certainly we would take questions after his lectures. I welcome you, sir, and I hand over the floor to you, to Professor Ashutosh Sharma.
Can you put up my slides there? Good afternoon to all. It is so delightful to see that the Goa is in fact taking this lead to bring, to inspire young people in science and technology and such a great participation. And indeed, it was so heartening to see that everybody from the Honorable Chief Minister, Dr. Sawant, the Chief Secretary, Mr. Rai, Honorable Minister of Science and Technology, and a whole lot of stakeholders from Goa, including, for example, IIT Goa and CSIR, where we are now. In fact, Public Service Commission, Mr. Narona, and everybody, and these great speakers that we have had before us, basically attest to the importance that Goa attaches to science, technology, and innovation. Indeed, science, technology, and innovation is all the future on which would ride the humanity and indeed our life on planet Earth. So what Goa, in fact, is doing today should be a very good template, a very good model, in fact, inspiration for other states. Where if we ignore science, technology, and innovation, we ignore the total potential that the mankind, the humankind has living on this planet. We have had very inspirational 2 lectures, and it's always the duty of the last lecturer to round off the time limits, and I would try to do my best in doing that. This is a very important, very weighty subject that we consider together. Indeed, preparing for the future. What is new about the future, about the science and innovation in the new millennium is basically what we would be looking at together. So actually we need really about 15 hours to look at this very carefully, and especially for the younger people who are here. This is all of their future. Another 50 years, this world would be an unrecognizable place. And what is it that we need to pay attention to now? That's basically what we want to do, and we want to do all of that in half an hour. So please bear with me a little bit. Of course, we stand under the banner of a great mind, Shri Manohar Parrikar, as we already know, but there are some lessons from his life and his times about being a scientist and about science. And this is something that I want to convey very, very quickly, of course, that there are a whole lot more things about him, but I'm saying just what are the limited aspects which are related to science and the theme that we want to talk about today. First of all, whole lot of us think that the science, engineering, technology, whatever it is, the education that we learn is about the contents of that education, and we would not be, nothing would be more wrong than to assume that it's the concrete things that we learn is basically what constitutes education. Education, learning is about right analysis, synthesis, scientific temper, even common sense in solving problems. And Manohar Parrikar was a great example, even though we know that his background was in engineering, metallurgical engineering from IIT Bombay. It is the tools of the trade that one learns. This is what remains with us, not the actual content. We forget all of that. I mean, I know that from my experience. I'm not stupid, but I would have forgotten everything in 2 to 3 years after doing that particular course. And I'm sure that would be also your experience. So what is it that we take forward in learning? It is to take our learning anywhere, and doesn't matter what we do in life. And indeed, Shri Parrikar was a great example of that. This is something that all scientists, everybody who is doing science, ought to know. Second aspect that actually struck me as very important is overcoming adversity. Look, life doesn't remain the same, neither for a scientist, nor for research, nor for anybody else. It goes up and down. So it is about negotiating adversity and finding new opportunities in that adversity. When one is failing, let us say in research, anything, to actually build upon that without losing energy, and even under adversity to be doing my duty to the last moment. Is a great thing that I actually learned looking at him his last 1 year. You know, our personal circumstances can never take priority over our duty. And of course, education in mother tongue has never been a constraint. A lot of people think that if I don't know great English, then I cannot do great science and technology. Nothing would be more misleading than that. 80% of the world does science in their own mother tongue, and they do it great. I mean, whether it is Japan, Germany, France, what have you, they do it, and they do great science. And of course, Shri Parrikar, I know that he had done his high school, everything in Marathi. And so, you know, our success in life does not depend only on these kind of, you know, silly things that we keep believing in all the time. And of course, a science and technology graduate also has social obligations. Just because we are scientists doesn't mean that I'm confined only to my lab. Again, that's a mistaken belief that many scientists have, because it takes a bit of energy, it takes a little bit of less self-centered approach to connect our science with other sections of society who can benefit from it. And so it is science not only for myself, but it is, you know, what good it brings to different sections of society. So anyhow, I would not belabor that point anymore. Come right to the future. And we know, always remember, predictions are very hard, especially about the future. Of course, we all can predict about the past, but about the future, even if you were to go back 30 years ago, before the rise of internet, before the rise of mobile, before the rise of Google Guru and all of that, you would see that you would not be able to imagine the world in which we live today. Impossible. And certainly, the world that we would be living in 30 to 50 years from now is totally unimaginable. But while we do not know what products and technologies would actually be there are directions of future that one could predict, and I would come to that point very quickly. This is so important, because when you are looking at saying, look, what is it that I should focus on? What are the requirements of my society, my people? What are the needs and priorities? All of that one can figure out, and that would actually tell us the direction in which science and technology would be going, even if not looking at the exact stuff. Before we come to that, I just want to quickly share with you that India is number 3 in the world in the number of scientific publications that we put out there, which is great. We have been climbing this ladder very quickly. I know when I came in Department of Science and Technology 7 years ago, India was something like number 7 in the world, and just within this 6-7 years, our rate of growth of scientific publications has been great. It's about 12% year on year, compared to about 3% growth globally. So we have been, doing that. But, just because we do great in numbers does not mean that we do great in everything else. We must also know what our weaknesses are. And our weaknesses are that in terms of the quality or profundity of those publications or science that we do is little bit less than the numbers. The direction and relevance of that research that we do, and how we translate it in terms of new practice, in terms of new businesses, in terms of new opportunities. So you see, the translational aspect is very important, but translational aspect, which means converting knowledge into new opportunities, it does not depend only on the scientist. It also depends on the ecosystem around that scientist, for example, industry, whether they would take up that knowledge and convert it to a product and technology and so on. Anyhow, what we want to say is that, look, while I'm not talking about one aspect of science, but I want to talk about some processes of doing good science. Now, some of these processes, very important for doing good science in the future, starting now, is the power of what we call lateral thinking, creativity, and even common sense. Common sense is something which becomes very uncommon. It's not common at all after you do PhD. You know, you have a little bit more common sense in high school. We continuously lose it once you get into coaching classes, and beyond that, you know, okay, whatever, MSc, PhD, blah, blah, blah. And after that, one totally loses it. But I would try to actually show you that all the great scientific discoveries, you know, great leaps in science, in fact, happen because of what we may call lateral thinking, creativity, and common sense. And never ever lose that. It's not only about science, it's about everything we do in life. If we have lost common sense, we have lost 90% of the use of our knowledge. I can guarantee you that, because now, of course, the knowledge is not the knowledge I'm talking about in education. The goal of that knowledge is very limited because that's only about going from chapter to chapter, from exam to exam, from course to course, from degree to degree, and after that, it has no further meaning. I'm not talking about that. I'm talking about solving problems. Now, what is actually creativity? I thought very deeply about it. Creativity is not today's world E equal to MC squared. It is about connecting those dots of knowledge which have not been connected before. In other words, it's about finding connections between even social science and chemistry or anything, right, which is useful, which is exciting, which brings in a new direction in our applications, in our basic science, and so on. All the great major advancements in science will happen by creating silos of knowledge. Look, what we did 100 years ago, we took one knowledge, we fragmented it in 100 different ways. So we said there is organic chemistry, inorganic chemistry, green chemistry, red chemistry, biochemistry, physical chemistry, chemical physics, and then further subdivisions of each of these. Now, time has come actually to integrate those fragments. So it is not so much about analysis, but it is about synthesis, because problem solving needs synthesis. It cannot be done by analysis alone. So that's a very important point actually to remember. I want to give a couple of examples, because this gets a little bit abstract. I want to give a couple of examples about what do we mean by connecting the dots. Let's look at the first example. The first example is that of scanning, tunneling microscopy, atomic force microscopy. My group was among maybe the second group in the country to have an atomic force microscope or scanning, tunneling microscope working with them. What is it? It's basically these microscopes is to see small things on nanoscale. Much of the progress of nanotechnology would not have been possible without these particular instruments. This is in fact a good example of technology leading new science. We have often believed that it's the new science that leads to technology, which is true, but time has also come to recognize the fact that new technology also gives rise to new science. It allows exploration of new science, which otherwise would not have been possible. So anyway, microscopy, atomic force microscopy, for example, is to look on the surface and look at very small nanoscale things. Now, how is that made possible? When we think about seeing something, we're always thinking about light. The way we think about seeing something, we invariably think about light because this is the way we see. Or we think about radiation of some kind because, like electron microscopy, we look at some kind of radiation. But is that the only way to see? You think about what is the concept of seeing, not the act of seeing through eyes. The concept of seeing, one can see in many different ways. Think about how a visually challenged person sees. How does a visually challenged person see? Well, you close your eyes, you take a stick, you go about tapping it on the surface on which you walk, and then you make a mental picture of that surface, isn't it? So if you were to do the same thing with a very small stick, which is a micro stick, it's called micro cantilever, and you tap it on the surface that you want to probe to visualize, then you would be able to make a map, a visual map of that surface. And you do that, with technology, you would get a nanoscale map of the surface on which you are tapping. So that is the basic idea behind an atomic force microscope, very simple. But the point is, look, whole lot of science in today's world is not limited by technology. It's limited by a new idea. It's limited by a new concept. And to bring that new concept, we must have a new ways of thinking about it. And this is such a simple example. It led to Nobel Prize a couple of years after, its invention, right? In good old days, Nobel Prize came when one of your legs was in grave. One did the work in 30s, 40s, and then one became 70s, 80s, and you are waiting for Nobel Prize and so on. But this is an example of a very impactful work that brings you Nobel Prize right away. So, and this is only, it's just based on the fact that I think about what are the different ways of seeing and how do I translate that in practice. Second example that I want to look at in doing good science. In good science, we must focus on everything that is happening, not focus exclusively only on what I want to discover. So, in other words, when I'm doing an experiment, I have some expectation from that experiment, and I ignore everything that happens unless my expectation is met. This is only a textbook experiment. This is only experiments we do in high school, in colleges, to get marks. Okay, it's a ritual. But a real experiment is not a ritual. It is a great source of understanding and new learning. And here is another example that got Nobel Prize very quickly in a couple of years, which is the rise of graphene. Graphene, those of you who don't know, it's a miracle magic material, most famous nanotechnology material available for a lot of applications. And graphene basically is a single layer of carbon atoms. So a two-dimensional sheet of carbon atoms and two-dimensional material. So point is, okay, this is fascinating story. You can talk 10 hours, 20 hours about it. But I'll just tell you how graphene was isolated before you can actually work on it. So now, you see, this is an experiment that many groups around the world have been doing for many decades. The experiment is like this. You want to probe the properties of what is called graphite. So you take a block or a chunk of graphite, and you want to probe the properties of that graphite surface. You want a clean surface. To get a clean surface, you put a tape on the surface and peel the tape, so all the dirt is taken away. Very simple experiment. And then what did people do? They threw away the tape, all the dirt that comes off from graphite block, and kept the graphite block to look at it. Now this group, what did they do? They did the reverse. They threw away the graphite block and kept the tape. And look at the tape. Now, because graphite has very low degree of cohesion in carbon atoms, so when you peel the tape, sometimes a layer of carbon atoms would actually get deposited on the tape, right? So it's like, don't throw away everything or anything, right? Because most of the interesting things actually come from there. They come from what we throw away. And a whole lot of science, good science, happens by serendipity. It happens by serendipity, means by chance. But serendipity helps those who are prepared for it. It's not, it's like, somebody, the opportunity knocks, but we don't open the door because I am only want the knock at a particular time, at a particular frequency on my door. So that's not how opportunity actually knocks. It comes unannounced, and if we are prepared for it, and then this is how much of the good science is done. It's not simply done by some linear thinking, opening a textbook and following everything which is given there. The third example and the last example I want to present here is from my own experience in my own group. Because we have been working 25 years on nanotechnology, in particular nano fabrication. What that means is you want to make small things. How do you make small things? Now, one of the way you make small things is how it happens in nature. It happens by what is called self-assembly and self-organization, and in fact, directed self-assembly, because information is built into these molecules, these particles, if you would, so they come together to make something bigger, but with a purpose and with a structure and with a architecture which is really coded into that. Another way to make things, mostly humans, the way we make it, is called top-down techniques. Top-down techniques, you take a machine tool, it may be small, something, radiation, and then you make things. Like just like we make big things, we make small things, but with different tools of nanotechnology. Those are called top-down methods, whereas self-assembly is called bottom-up method of doing things. Okay. So now one day we are thinking about, look, is there a third way of making small things? And I recalled actually a very nice, interesting movie that I watched in 1980s. It was just a few years before most of us were born, I think. But anyway, 1980s, this movie is called Honey, I Shrunk the Kids. Now what is it? I mean, it's a fantasy. You have something big, you can shrink it, you make it small. So he said, why can't we do the same thing, no matter how absurd the idea looks? Why can't we do the same thing to make small things in nanotechnology? You make something big. Making something big is easy. But to make something small, the effort and time and money required grows exponentially inversely with size. So you make something small, it requires much, much more effort and tools and stuff. Okay. So well, how do you do that? So basically you start with a concept. Like I said, think out of box, think absurd, think any which way you like, and then see how do you translate that idea in practice. So how do we do that? You think about it, say, look, we can do indeed the same thing, or you can call it miniaturization. And so you take the object, let's say you made a 10 micron object, which is easier to make a complex 3-dimensional object, and then do molding. Molding, take a gel and make a negative replica of it. Then you shrink the gel, then it shrinks smaller, make another replica, repeat the process, do until you get the right size. So every generation of doing this would shrink the original object, let us say, by maybe 5 times or something. So you do the iteration. This can be done in a high school lab to make something 3-dimensional and complex by just using common sense, if you would, and using a concept saying, look, I can shrink things and therefore I can make small things. Very interesting. And there are hundreds, thousands of these ideas that you can actually get. In fact, Dr. Yonath, the Nobel laureate that she was talking about, and before him, in fact, Dr. Kasturi Rangan, they were talking about nature-inspired science. This is another very, very interesting idea. Now, a whole lot of us actually work only with textbooks. We work with books. We sit in library. We look at, the PC. We work with those things. But we hardly ever go out and look at actually what is out there. It's a storehouse of great science and technology. How nature does things. It is so, so wonderful. It's so exciting and inspiring. And I just give you, let's say, some examples. Some simple examples of what we may call functional materials, smart materials, functional manufacturing, and so on. I already pointed out the fact that manufacturing in science happens completely different way than manufacturing done by humans. In fact, all of nature builds with wet materials, soft materials. We build with hard materials, metal, under extreme conditions and so on. And we build bit by bit. We take a bit, we take a hammer, we chisel away and so on. But look at how nature does it. I think human technology would take many millennia before we even reach anywhere near that magic of nature, if we are still around that long on planet Earth. But anyhow, here look at some simple examples. These are called structural colors, very vibrant colors of peacock feathers. of butterfly wings. These kind of colors are not found in man-made pigments, by the way, because they are not actually made with, they are not, they are called structural colors. Colors arise because of the micro and nano structures on the surface of these materials. Lotus effect, which is water repellent surfaces. If we make paint and coatings that mimic this texture, then it is great that we can have water repellent any material. Now look at the ceramics which are made in nature. Human-made ceramics are under high pressure and temperature. But look at these beautiful ceramics made at room temperature. It may take a little bit longer, right? So how do we, these are all the stuff that we can learn. Look at the final example, bioadhesion. Gecko and frogs and insects, they stick on the surface, they walk around the surface, they can change their adhesion strength, and they keep using this stuff for the rest of their lives. But all of us, we stick a poster with a tape, then we remove the tape, we can't use the tape again. So you see, this adhesion is so different in nature as from what happens in man-made materials. I don't know, I hope that you were not taught in your class that is because of some micro suction cups on these sticking pods. There are no micro suction cups. There are no suction cups. That's a completely wrong interpretation and explanation for this effect. So what is right? Well, it's because of micro, nano projections here, if you would, that come out from the surface, that do the job. Anyway, all of these are very complex scientific stories. But the point is that they all provide new science, new insight, and new technologies which come out from these things. So this is where we need to pay attention in the future. And of course, nature-inspired technologies is a very big business, very big, very important, very, very exciting business, if you would. It's about new materials, it's about new methods of manufacturing, new devices, machines, new functions, and even new principles, if you would, new insights and new wisdom. Let me just give you one example of wisdom that one learns from nature, even though we think that we are doing it ourselves. No. See, this is about respecting diversity. Respecting diversity, respecting inclusion and equity. One of the examples of that, for example, is a huge gender imbalance in doing science and technology in all countries, not just in India. Right? I'm very happy to see that there is a good balance of gender here. But if you were to look at, let's say, certain areas of technology, even medicine and so on, if you were to look at the career progression beyond, you would see that somehow there is a great deal of imbalance there. But you look at nature. See, nature, we sometimes think nature produces optimal things. Actually, nature doesn't give a damn to optimality. Of course, there is some optimality that is achieved within a given set of environment and conditions. But it gives great deal of stress on diversity. Why diversity? Diversity is basically doing the same function in many different ways, by many different people, by many different kind of mechanisms, if you would. So diversity, of course, is obvious. If all of us were very optimal people, all of us were Alexander the Great, let us say, or Einstein or somebody, but we were all carbon copies of each other, we were all clones of each other, then the first virus that strikes me dead will strike all of you dead at the same time, in the same way. So no matter how optimal we may have been under a given set of circumstances, we would not retain that optimality when a new challenge arises. So therefore, to have a robust society, to have in fact robust science, to have anything robust, we need to have understanding, respect, and leverage of diversity. So important. This is so important for science. And this is about, hey, how much time is there? You see? Okay. Let me change gears a little bit and go a little bit faster. We will not take any questions. No questions about questions. So let me finish this work here. And then if you have questions, feel free to drop me an email or something. In the next 2 weeks, I will get to it, no doubt. Okay? So, all right. What we want to do is that, look, we want to talk about the future. And we were saying, look, what do you think will happen in the future? So we don't know what will happen in terms of a specific product or specific technology, but I can tell you what is we need to watch out for. We need to watch out for what the mind wants. Okay, and if you were to look at what the mind wants, there would be a new product, a new technology to address what the mind wants. The whole history of humanity has only been that. So we want to be healthy, quality of life, to be connected socially and otherwise with equality. We want to learn and to apply that knowledge. We want to make decisions in complexity with arm load of data. And in response to that, we get artificial intelligence, machine learning, and so on. We want to be entertained. I mean, in a metaphorical way, this term entertainment. Many of the meetings are also entertainment. Many of the conferences are also entertainment. It's not just, everything, but entertain. So new technologies for that, to have a better life, to be happy, to have fulfillment, to create and control our own world. You see, imagine we are so unhappy with people around us and circumstances and the boss and everybody else and the teacher. We always saying, look, can't I be the creator of my own world? Can I not control it? And in response to that comes the technologies of virtual reality, augmented reality, mixed reality, and so on. And these is what is going to pick up really. 20 years from now, whole lot of us actually would be living in a virtual world. Not because, I'm not talking about ethics, morals, or being a human about it. What I'm talking about is, this is what satisfies the mind and the cravings of the mind. Is saying, I can be the king of my castle, so to say. So this is going to happen. To live long, maybe forever. Right now, of course, nature has provided one pathway, which is through propagation of DNA. It is not a coincidence that I like my nephews and nieces and my children and so on. This is because of the fact that the DNA, the genes are selfish. And nothing will actually falsify that very deep biological imprint that we all have in the mind. But now there may be other ways of doing this, digitally, cybery. So what it means is there are digital twins, there are cyber twins, there are simulations, there are all of that stuff, which first comes from the industrial sector, Industry 4.0, but it will get into us, have no doubts about it. So just think about, suppose all my experiences, suppose everything I have seen and heard, and my interactions and my thinking could be downloadable. I'm carrying cameras and everything in one place, and then this persona or personality is powered by artificial intelligence, and it keeps getting more knowledge from the world even after I cease to exist as a biological entity. So imagine today if Gandhiji was around, or Shri Parrikar was around, okay? Around not in the physical form. It could be, of course, it can be a hologram, it could be a projection, it could be something, doesn't matter, but in the mind. So all those experiences, if they were there and reading news every day, new input coming in, and then some decision-making engine like machine learning, right? Then, you would be able to interact with these people, and they would keep growing as a persona, not as a static robo, so to say. So these are very amazing possibilities which are on the horizon. And indeed, I guarantee you, all those people sitting here, mark my word, 20, 30 years from now, you would actually be dealing with all of these things. I would just list out 2 challenges of the future, okay, around which would revolve all of your science and technology and innovation of the future. The first challenge, which is also an opportunity, is the rise of intelligent machines. Now, the future is all about the convergence, not only different streams of knowledge, but also about different technologies. So convergence of materials, machines, communication, perception through sensors, computing, which may be at the edge and distributed everywhere, autonomous decision-making, autonomous control, and autonomous action through actuators. This is what we call in rudimentary form Industry 4.0. The machines that are self-correcting, self-learning, self-implementing, so to say. Okay, but then the next frontier would be convergence of biological with the cyber physical. So right now it is the convergence of digital and physical, and we may call it cyber physical. But the next big frontier is that this cyber physical also takes a bit pieces of all the way from DNA to chunk of biological material and integrate it. And finally, this entity gets in my body and my brain. It's not science fiction. This is going to happen because would bring advantage to the mind that makes use of it. Anytime there is an advantage, people would flock for it. That technology is going to succeed. Look, even technology like quota, coaching classes has succeeded. How it succeeded? Because as soon as I seen there's an advantage from my neighbors' children going there and they crack JEE, every parent is going to run after it. Okay, it doesn't matter if it's ethical, it doesn't matter, what the hell it is. Okay, it's going to happen. So it's going to happen in greater and greater proportion over time. So there is a first challenge, and like I said, huge opportunity. So point is to tap into this opportunity of doing science, technology, innovation. One has to not be very siloed in terms of my knowledge. We have to work with other people. We have to totally understand what is happening, and in fact, be delighted in meeting and talking to people who are not like ourselves. You see, everybody I see, they are very comfortable with other people plus minus 5 years of age. We are also very comfortable with people who dress like us, who eat the same food, who speak the same language. But to crack good science, to do good technology, actually we need to talk to people who are not like us, no matter if it's not psychologically comfortable for us. It's about getting out of comfort zone and working on it. So anyhow, these cyber physical futures or digital physical futures, they have impact on everything we do. It's not about the lab, impact on lab, very small, that's a very small matter. It's not about only impact on my cracking exams, very small matter. They have impact on who we are, our basic of who we are, how we organize ourselves as a society or as an individual, and at every level in between. It's about learning skills, education, work, monitoring, governance, experience and entertainment, mental health, judiciary, commerce, medicine, privacy, safety, you name it. Challenge number 2, which is the overarching challenge of humanity on planet Earth for all foreseeable future. It has a beginning but no end, which is the sustainable development and climate change. 50 years ago, people like me, everybody, my generation and before, thought that this party we are doing, this technology party, is forever, that this would never stop, that we would just keep consuming more and more, and this was the key to happiness of the future. We couldn't be more wrong. Okay, so this is about understanding the lights and shadows of technology. Anyway, I've run totally out of time, not my original time, but my readjusted time. So I would not belabor this point too much, but to say that the new challenges and opportunities of science and technology, whole lot of them are going to come from here, from sustainable development goals. And you can read them. It's about everything. It's about poverty, it's about health, it's about water, it's about medicine, it's about education. We have to find, you see, science and technology cannot be viewed in isolation. Okay, that is a mistake that the education I received somehow convinced me that science and technology are these textbooks, chemistry, physics, biology. They couldn't be more wrong. Science and technology is in everything that we do and will do. Okay, it's a question of recognizing what are the pillars of this science and technology that would help me address sustainable development, or help me, promote sustainable development. In fact, if you think about it, sustainable development is an oxymoron. An oxymoron is basically two parts of the word that are in conflict with each other. They mean something different. Why are they oxymoron? Because understand that the way we think about development today, this concept, this definition of development is actually very recent. It's only about 100 years old, where people start equating development with consumption, or economic development, which is through greater consumption. There is no concept of responsible consumption, for example, recycling and all of that. So that concept of development will always be in conflict with sustainability. Okay, so now another point that I want to introduce here, a lot of my younger friends are there, that you see science, technology to solve problems. It is one aspect of solving problems that face humanity. It is not the totality of things. And so to integrate, actually to have understanding of the totality of things is what would help address the problems. So for example, when we talk about sustainability, we talk about climate change and so on, and constraints on environment and so on, raw materials. It's not only a problem of science and technology. It is going deeper down into the will of the society, the culture in which we live, the way our mind works, the policies, the rules and regulations, everything plays an important role as the interaction between science and technology with these larger ideas of society is what determines the outcome. Here is something I liked, and I like quoting. This guy is saying, I used to think the top environmental problems were biodiversity loss, ecosystem collapse, and climate change. I thought that with 30 years of good science, we could address those problems. And this is how we scientists actually think about things. We are always saying, there is a problem, I will fix it. Right? I'll find some science and technology that will fix it. But I was wrong. The top environmental problems are selfishness, greed, and apathy, which is the opposite of empathy. And to deal with those, we need a spiritual and cultural transformation, and we scientists don't know how to do that. By the way, what he's saying about scientists is true for every section of society. Okay, and there's nothing wrong with it, because that's how we are biologically created, is to be selfish creatures. Okay, nothing will ever change that. Okay, no amount of moralizing or giving lectures and stuff will change that. So therefore, the only thing that changes is to understand, okay, for each one of us, as to what is it that helps us truly, what is the meaning of being selfish? Is the meaning of being selfish is only limited to this body, this mind, or the selfishness is a little bit bigger? It extends to my family, it also extends to my descendants, it extends to my society, my nation, my globe, and so on. Okay, so I really said I've run out of time, and I have. So when we said, look, we got these big challenges of science and technology in the future, we have to prepare. There's only a holistic mind that can deal with these challenges. These challenges cannot be dealt by me alone or you alone and so on, and a fragmented mind. It has to be a holistic mind. But two things I always remember in doing good science, and this is not new. Okay, one of the original scientists 2,500 years ago was Buddha, because he said, believe nothing, no matter who said it, no matter if I said it. So he may be a guru to many people, and people blindly believe in their guru. No matter if I said it, unless it agrees with your own reason and with your own common sense. And I may add to that your own logic and experience and so on, right? It's very similar to what Royal Society, their motto, which says, take nobody's word for it. But that is much later, okay? This is the beginning of the modern science, if you would. Of course, everything looks more impressive in Latin, Greek, or Sanskrit, but it means the same thing, okay? In common, terminology, you say, take nobody's word for it. This is a very important lesson, because I have often seen, and in fact, this is so cultural in India, that we read something and we start believing it. I have had so many PhD students running to me and saying, sir, this great university XYZ, they have written this paper, and so it must be gospel truth. There is no such thing. In fact, only by critically examining and questioning, no matter if this Nobel, Prize winner has said it, no matter who the hell has said it, we must have healthy irreverence for ideas. I'm not talking about irreverence for people. I'm talking about irreverence for ideas, because that is how science, in fact, would progress at all. And great science is done only by irreverence. Look, there are two different models of learning. The first model of learning, which says, I would sit at the feet of my guru and learn. That model of learning is good when you need passive transfer or transmission of knowledge. Another model for learning is, I would stand on the shoulders of my guru, right? This is the model of West, not Oriental model. Oriental model to sit at the feet of your guru. And like I said, that's good if you just want to learn what guru knows. But if you want to see farther than what your guru knows, you must have the discourtesy of climbing his or her shoulders and stand on them to be able to see farther. And there is no paradox in this, there is no disrespect implied in it, and we must be able to critically question everything that anybody says, and so on. And so, like I said, we stop there. We could stop here. I think this is the final concept that I want to convey and clearly let you go for lunch. And the reason I want to convey this is because there's a great deal of misunderstanding about what is innovation. Now, because we start talking about innovation, in fact, great deal of misunderstanding not only in students, their teachers, professors, practicing scientists, everybody. 90% people, I assure you, would fail in providing the correct concept of innovation. Okay, so having said that, because innovation has become so important in the modern world. Innovation, first of all, is not simply a brilliant idea. It's not simply a creative idea. Okay, not simply somebody saying, oh, great, what an innovative idea. It's none of that. So, to understand innovation, and in fact to understand holistically the whole movement of knowledge, let's look at two different things: invention and discovery on one hand, and innovation on the other hand. What is invention and discovery? Basically, think of this as a black box. We don't know what is inside it. But what comes in the black box, input, is money and resources. And what flows out is the knowledge, right? So this is what you call invention and discovery ecosystem. All the R&D labs, universities, IITs, ISERs, colleges, what have you, they are part of invention ecosystem. Because, government is supporting this function, right? Government is supporting everything, education, research, and so on. So it means that we need money to flow into this black box, and that generates new knowledge, which can be transmitted, and so on. Innovation, on the other hand, is 180-degree out of phase with invention. Its process, the process of innovation, the structure of innovation, the architecture of innovation is mathematically orthogonal to processes of invention. Now, what do I mean by that? Think of innovation as another black box number 2. The input to that black box is knowledge, and what comes out is the money, okay, or money or new socio-economic opportunities. So you see, it's just completely, it's a black box turned around. So invention produces knowledge or transmits knowledge, whereas innovation creates new resources from that knowledge. So it's transforming knowledge into money. Invention is transforming money into knowledge. Unless we have invention and innovation working together, the knowledge ecosystem itself is incomplete, impartial, and would collapse. So it is obvious that we are getting more and more knowledge, but we don't have money to support in the future that knowledge. So which is why it is so important that today's youth is in fact is taking that opportunity to making use of the knowledge that they have learned in colleges and everything, by rolling our sleeves, taking risks, doing things. I love talking about jugaad, dhanda, and panga, but maybe some other day, not today. And so to succeed in a complex world of invention and innovation, there are some things we need. First of all, the thing I always tell in convocations and stuff, I say first thing we should do is lose what I call energy vampires. These are totally negative people who see nothing right in this whole world. You hang around with them for 2 hours, you'll become a zombie yourself, good for nothing. Okay, you go around like this saying, okay, this is the end of the world and so on. Nothing is ever done by people of that kind. Okay, so lose energy vampires, they suck energy out of you. Teamwork is very important. See, each one of us in our school, in our college, we have succeeded because of individual brilliance. So it has conveyed to us only a partial message about success in life. The individual brilliance is very important, no doubt, but it's necessary condition, but it's not sufficient. No, I have seen Einsteins fail miserably if they want to run a business. Okay, they cannot run a business because they know nothing about teamwork. Their model is only competition, not cooperation. So other half of life that we have not learned is cooperation. And the first one is competition, and we have succeeded from that, which is very good. But don't ever believe that this, that we would succeed only by this mantra of competition. I talked about diversity. Finally, I would just say soft skills, communication, taking responsibility, so on. This is so important. No matter if you are a science person, no matter you are a scientist, no matter who you call yourself, okay, I've never seen a good scientist who doesn't have actually, who doesn't have not just IQ, but also an emotional quotient and also have empathy quotient. So these two things become so important for a holistic science, a holistic scientist of the new millennium, that we have IQ, we have competition, we are cutthroat and everything, but to succeed, to solve problems, to make sure that science actually translates into action, what we would need is empathy quotient and emotional quotient. In fact, maybe even more important than IQ, so to say. And so, I indeed conclude here. Future is convergence, so pay attention to other things that other people are doing. Driver, blah, 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 okay, forget about it. The best way to predict the future is, in fact, to start working on it and not to wait for other people to tell us what the future would look like. And in fact, I've said, some of you might be aware of these models of pandemic in COVID-19 time. He said, it's predicting second wave, this intensity, third wave, that intensity, whatever, right? What does it all mean? It means nothing. There is no mathematical model that would ever predict anything of this kind, or for that matter, nothing which is related to, which is influenced by human behavior, right? So what does it mean? It means future is what we will make it. Okay, so if we are going to be doing this, or if we are not going to be doing this, it's going to make different futures. And those futures are totally for us to make and write. Make no mistakes about it. No amount of science, technology is going to control our freedom of action and the role of consciousness, which is not factored in equations anywhere. Okay, there's one big thing about science and technology. We often forget that the humans are complex, our mind is complex. It gives us a freedom of action, which is not captured by passive equations. So be your own man, be your own woman, do great science, and I wish all of you that and a lot more. Thank you very much.
Thank you very much. I think what a brilliant lecture. I think we should all give him a standing ovation, actually. So wonderful. It's not just about science as a material truth, but also sir has actually spoken much more beyond what the scientists to do in terms of achieving. But I think the word emotion and empathy, most often we do not find in the science textbooks, but I think what scientists can make through these two words emotion, empathy, is that we are creating a world that is just for all the life to survive and exist on this planet. Thank you very much for such a wonderful lecture, sir. And certainly we as at the Department of Science and Waste Management, Government of Goa, would like to have your guidance in our future in creating an ecosystem that drives the society with scientific innovation. At the same time, also brings that the quotient of emotion and empathy among all the citizens of the state. I also would like to, this is a, we are coming to an end of this 3 lectures, wonderful lectures that we have. Brilliant minds have spoken about their own field of expertise. I thank all these 3 eminent scientists, Professor K. Kasturi Rangan, who has been, who has been instrumental in taking ahead the science of astronomy and space sciences. And what today we are talking to each other, not only in this hall, but also we are talking to each other sitting remotely. So the space science has made this possible, and what Sir basically spoke about the advancement in space sciences and what we need to take further is immensely helped not all of us. Professor Ada Yunath, unfortunately, she could not be with us online because of her health problem. But we also would like to thank her for giving us a wonderful presentation on antibiotics and also speaking about ribosomes. Of course, Sir Ashutosh Sharma, sir, thank you, sir, for being with us physically and speaking to the audience of 5,000 students across the state. And here in the NIU campus, we have more than 600 students participating both in this cardium as well as in the seminar hall. Your knowledge and experience would certainly go a long way in making and creating a world and the state taking us towards the path of sustainable development. I would also like to thank the creator and the person who actually thought of this festival way back, I think 3 years back, is Mr. Levinson Martins, who actually by me, and he was sitting in his chamber and suddenly thought, he put an idea that Parrikar sir was so close to all of us and so immense knowledgeable in terms of science and technology. He wanted to create a society of a rational mind and scientifically thinking mind. And he had actually committed himself during his talk in Nobel Prize series that my government wants it to be an annual feature. And how do we actually take this further? I think we sat and suddenly we thought, why don't we speak to another person who was very close to him, Jose Manuel Nerona sir. And we went and spoke to him, and he liked this idea so much that let's get into this. And so this is where we created something called organizing committee in 2019. And since 2019, we have been doing this tirelessly, and we wait for this particular date to come. To add to this enthusiasm, Professor Sunil Singh has been great help for all of us in identifying these lectures, getting them together, and whenever we require his support, he's always there, sir. And this is so wonderful that we have been doing this particular event right from 2019 in this cardium with support of Professor Singh and his team in NIU. Thank you very much, sir, for this hospitality. Thank you to all the advisory committee members, the Director Bits Pilani, Director IIT Goa, Mr. Dr. B.K. Mishra, Director NIT, Dr. Gopal Mugeria, Professor M.K. Janardhanam from Goa University, who have been instrumental in guiding this force under the able chairmanship of Sri Jose Manuel Nerona. We have been able to achieve this. thank you for this wonderful minds who are advising on this journey. Thanks to all the young minds, young brilliant staff of Goa Waste Management Corporation. A wonderful time that we spend. We sit in the office as a group of people, discuss the ideas, and we tell tomorrow we need to do this. Tuck, it comes answers. So don't worry about. We are all there. It's wonderful. I think we must give a big hand to my colleagues at Goa Waste Management Corporation, who are young dynamic force, and I have absolutely no doubt that they would certainly take this torch ahead and make this particular event much memorable and befitting respect to the departed soul, Shri Manohar Parrikar. Thank you very much. Thanks to the allied, Department of Science Technology staff, Department, Goa State Council of Science and Technology staff, and all of them who are actually part of this thing. Thanks to the expert scientists. This year we consciously took a decision to appoint and ask expert scientists to be in each of these venues in order to facilitate the online lectures. Thank you very much to all the expert scientists who are in the cardium here, and also all in different venues. Thanks to the event management company, Mr. Siddesh and Mr. Aaron, who have been with us for the last 3 years, and so doing a great job and making all things possible for online lectures. Thanks to the Honorable Minister, Chief Minister, Government of Goa, Honorable Minister for Science and Technology, and media for covering this. Without the support of the government system and without the publicity support, I think we would not have reached to number of people that we are reaching today. It's not just in the state of Goa, but also we are reaching across the globe. So your contribution and your support will certainly be helpful, not today, but also in the future. Thanks to all the moderators, thanks to all the venue in charge. We have 7 different venues apart from NIO, all the venue in charges, and our coordinator from GWNC, venue in charge from the institution. I profoundly thank on behalf of GWNC and the organizing committee and advisory committee to all of you. Special thanks to, again, I wish to reiterate my special thanks to Sri Jose Manuel Naruna for making us comfortable. I know that every time we go to your office, sir, you are so gracious in accepting us and giving us so much of ideas, spending so much of time with us and ensuring that this particular science event becomes really a science event. Perfection is what I've learned from you, sir. I think that will go a long way in my career as a scientist, because I know the science is perfection. But we human beings, what sir said is we are all organic mind. We think differently. But I think your teaching as a perfect man certainly will take me a long way, sir. Thank you very much for this thing. Thank you again. Thank you again to Professor Singh. Yes, sir. I think wonderful to be with you, and certainly we would be looking forward for your support in future too. Thanks to all the students community. I think without your support, without your participation, would not have been possible. I know that you are sitting here for last 4 to 5 hours. You have come here at 8:30, and to even now 1:30. You were there sitting here, and I hope I'm sure the talk that you heard will certainly motivate you and encourage you to take a path of science in making humanity better on this planet, because science is an enabler, and society is somewhere I think we all live actually. We require an enabler that takes us on the path of Buddha's teaching, or teaching of all our saints who have actually made us, looked at us as a human being. I think we need to be as a human. And also respect all other creatures that we have on this planet. Thank you, all the students, teachers. I also would like to thank three major departments who have helped us. Department of Education in communicating to the teachers, requesting them to send you all here as a beneficiary of this. Department Directorate of Higher Education, who has always been with us since 2019. Department of Technical Education. I would specifically thank Dr. Deepak Gaitonde. I think he is here, a great friend of mine. He has been helping us communicating to all the colleges, technical institutions. Thank you very much to all of you, and we will certainly would like to see next year on the same day, perhaps in the same venue, on the same podium. Thank you very much. Thank you all.